Decentralized energy from waste systems powering the circular economy. The future of energy for local communities. Innovation, compliance, sustainability. Brought to you by industry leaders Tidy Planet, Sujimat and Taboden. But what are decentralized energy from waste solutions? Tidy Planet's decentralized energy from waste systems are implemented on a local scale, enabling communities to minimize the transportation of wastes such as refuse-derived fuel and solid recovered fuel, significantly reducing pollution levels as a result. And due to their reduced size and localized nature, they're easier to connect to local consumers, meaning any surplus heat from the EFW process can be utilized to power industry and housing, instead of it simply being lost like it is in larger-scale plants, meaning local waste benefits local communities. And how do these smaller systems work? Waste is collected in a refuse vehicle and transported a short distance to the local recycling facility, which houses the EFW plant. The trucks don't need to travel far, reducing both transportation costs and vehicle emissions. Once it has arrived at the plant, the recyclable materials are recovered and the RDF starts its journey to becoming energy. The RDF is deposited into the fuel bunker, where it makes its way on a conveyor belt to the plant's furnace. Sujimat's computer vision system, an intelligent boiler monitoring and control tool, continually observes the furnace, automatically regulating airflow, grate movement and fuel feed to optimize the combustion process for maximum efficiency and minimum emissions. The hot gases which arise during this process then pass through to Sujimat's Horizon Plus rotary boiler. The self-cleaning rotating technology is designed to process dirty fuels with a high ash content, like RDF and SRF, minimizing any loss of efficiency. The rotating motion of the Horizon Plus and its sand cleaning system causes the ash to fall off the boiler tubes, keeping them clear of residue and therefore elevating performance and maximizing plant uptime, guaranteeing 8,000 operational hours per year. Upon leaving the boiler, the gases are filtered and treated by the flue gas abatement system before they leave via the chimney stack. The heat that passes through the boiler is recovered and transferred to the thermal oil that is circulating in the boiler's coils. This oil is pumped from the boiler to the Taboden organic Rankine cycle turbo generator in a closed-loop circuit. After the oil has transferred its heat to the ORC, it returns to the boiler to be reheated and continue the same process. The heated oil enters the ORC evaporator, transferring its energy to the ORC's organic fluid to produce vapor, and this is what drives the turbine to generate electricity. After the turbine, the vapor is cooled, condensed, and pumped back to the evaporator to be reheated. The organic vapor condensing system may dissipate the heat to maximize ORC energy efficiency or recover it for CHP. What happens to the electricity in surplus heat? The combined heat and power approach means the heat that is recovered from the organic vapor can be used to provide a hot water circuit for use in local industry or housing. Meanwhile, regarding electricity, a small percentage of it is used to power the facility, and the remaining electricity is sent to the local grid to provide power to the surrounding community. And at night, when domestic demand for power is reduced, the electricity can be used to produce hydrogen, a fuel that's then used for public transport, and the waste collection vehicles that are setting off on their journey to do it all again the following day. Powering the circular economy. Decentralized EFW systems present a truly closed-loop solution, which help to power communities, reduce pollution levels, maximize return on investment, protect the environment, and create a truly circular economy.